Oh, okay. We are going to talk about the lab hopefully later today. Hopefully get that graded. We'll see. And today we are talking about slope again, except in context of questions that you can see on your the purple slide that says Game Boy. I'm going to pause for just a second. Okay, so now I've got it's working in class so the kids can see the same thing I can. And we are going to find and interpret C of 0. Well, what in the heck is C? Look at the very first sentence. What does it say C is? The cost in dollars. I guess I'll have to wait till you get there. All right. Number 2. How many porta boys can be produced for $15,000? Well, where would I put the 15,000? C of X. All right, so if I was going to do that, I'd just have to zoom in on this and put a 15,000 right there and solve. That wouldn't be too tough. What is this X is greater than 0 thing? It's called a domain. Why would we need that? Do you think you're going to produce negative numbers of units at your factory? Probably not. All right. Explain the significance on the restriction on the domain. That's what we're talking about. And then find and interpret C of 0. Wait a minute. There would be a cost even though you produce 0 units? Yeah. So if you have a factory, it costs you money just to have it open. And the fact you have the factory is costing you money. All right. And then find and interpret the slope of the graph. Oh, I can look at this thing and know what the slope is. That's pretty easy. The slope, generally speaking, on a simple one like this is just the number that's right here. But if I just wrote 80, I'd get it wrong because this is a word problem. 80 watts per what? The cost goes up $80 for every, what? Portaboy game system that you build. Do you get when they sell you an iPhone, it actually costs them some money to make an iPhone? It wasn't just free for them to make that and then they sell it to you, okay? So if they sell it to you for like $1,000, they might have spent $350 or $500 or something like that to make it. Now, I'm not saying that they spent, you know, like a lot. They probably spent half what they're going to sell it to you for. All depends on their margin, you know, how much their markup is. There are some items that are very low markup. So like when you go into Best Buy and you buy a TV set, those are notoriously low margin, as in they might only make 5% on that sale. So in other words, if they're selling you a TV for $1,000, they might have paid $950 for it. They really, really want to sell you the cords. Have you ever noticed that? They really want to sell you the other stuff that goes with it because they make a much higher markup. They can actually make more money on selling you a USB cord than they might make on selling you the whole TV set. Which I know seems crazy, but it's true because their percentages are so much better on the cords. They might only spend $2 for that cord that they sell to you for 20, and then they make 18 bucks. And on the TV, they might have maybe paid $950 for it and sold it for $1,000, and they made 50 bucks. They almost make as much selling you a couple cords as they do the whole TV. All right, so moral of the story, this has real world implications and you have to be able to look at the units and figure out what those mean. All right, so this next one, I don't want to just go through all of these questions, but do you get that this one does not give you an equation? You would be responsible for writing an equation. We're not going to make these super complicated equations, okay? But this is a good real world skill. I've seen it on the ACT a million times where they give you a word problem, they don't give you the equation, you have to write the equation and then solve it. I don't need you to do all of this, all of it, but I want you to find the linear function which fits this data. I'm going to pause for just a second while you try to write an equation, kind of like last time, where you're going to use X number of porta boys, and the price is P. I'm going to pause for a second while you give this a try. Hint, they gave you 2 points. They really gave you 2 points. Don't you know how to take 2 points and make it into an equation? So they just gave you 2 points that are kind of real worldy. Pausing for a second. If you're having trouble getting your head around this, I'm going to make a little tiny chart here where I say P and G. And this is a good strategy for you to use when you're stuck with something. Is make a list. Okay, so when it was P was 220, price was 220. Then the number of game systems you'd sell was 20. If they were 190 bucks, then you would sell 40 of them. Do you get that if they sold iPhones for $40, they'd sell a lot more of them? Yeah, everybody'd have one. You'd probably have 2 or 3. And you wouldn't worry about breaking them, and that'd be great. But they don't do that. The more the price is, the higher the price is, they're not going to sell as many. Would you agree if they make the phone $5,000, there'd still be some people who would own it? But not many. Very few people would buy one if they were $5,000 each. In fact, though, I could have said 5 years ago, like, if iPhones were $1,000, nobody'd buy one. But that's kind of what they are now, and so people still buy them. So they kind of try to find that price that people are willing to still pay. And this last time, it seemed like they corrected a little bit. This last time they came out with iPhones, they came out with 3 of them. They were all kind of a little lowerish. They didn't try to push it up super high. Not saying they aren't expensive. I'm just saying they stopped jacking the price up so much. Kind of took a pause on that. Because I think they said, oh, we're not going to sell very many if we keep putting it $200 more each time. So. Okay. Essentially, I gave you 2 points. That point and that point. All right. Now, which one of them depends on the other? Which one is dependent and which one's independent? I want to just talk about that for a second because the independent goes on the bottom and the dependent goes on the side. And therefore, the independent is like the X and the dependent is like the Y. The ultimate independent thing is time. You've heard probably that time stops for no one. And ultimate dependent thing is the price of something. I've had examples where they give you water for free sometimes. There's just bottles of water laying around for free. And then there's other times when I think the most I've ever paid is like $4 for a bottle of water. That's infinite difference in price if you divide the two. So, yeah, the price totally depends. And if you were in the middle of the desert and you had $80 in your wallet and you were dying of thirst, some of you are probably still too cheap to buy that bottle of water. But if there was only one bottle of water and it was your last $80, I'd still buy the bottle of water so all depends. It depends on how desperate somebody is for it. If there was this is going to be an interesting one down the road. If there was a super expensive way to replace somebody's heart, we're talking like $8 million. Can you see the interesting ethical dilemma there? Somebody needs a new heart. We can do it. Just costs $8 million. Ugh, sorry, too expensive. How do you say that to somebody? You know what I mean? So we have that kind of dilemma with some drugs right now, some pharmaceuticals, where my father-in-law was on one. It was $400 per day to take the pills he was taking. $400 per day to take the special kind of anti-cancer pills. And the moral of the story, he got some of it paid through insurance, and he paid some of it, and then they wrote off some of it, and he was able to do it until turns out it wasn't actually even working for his situation. So he paid that much money, and the cancer still got worse, and so anyway, there are some really interesting ethical dilemmas when it comes to price and the real world. Okay, so back to this. Which one is the one that I basically told you was dependent? Do you think of the two, could we control the price, or could we control how many would be sold? That we controlled the price. So, and the number of units that were going to be sold was the G. All right, Game Boys. I probably should have said X because they said X was the number of Portaboys, so I should probably put an X there. P and X. Okay, so I got 2 points. I could write an equation for 2 points. You'd need to figure out the slope. Since they told us this was x, we're going to put the 20 and the 40 down here. And the price, we're going to put the 220 here. No, sorry, 220 here and the 190 here. And I'm aware that I got a big gap here, so I'm going to make a little squiggly thing down near the near 0 to show that there's a big gap in my chart. Okay, and basically, as we sell more, we will sell more if we have a lower price. So it's kind of like that. Did I have it backwards? I think I do. 220 goes with the 20. Yes. No, that's right. There we go. All right. And now, if I needed to find the slope, I would just take the just the same thing you'd normally do, which is the y minus the y over the x minus the x. And that would be the 220 minus the 190, which would be 30, over the difference in the x, which would be 20. And simplify that down, 1.5. What does that mean? 1.5 chickens per bottle of water? No. And is it positive or negative? It's negative because it's going down. Okay, so as we decrease the price by 1.5, every time we decrease the price by 1.5, we sell another unit. That'd be a way to say it. Okay, so then that's getting into the interpreting the slope thing. The main thing I'm trying to show you is that these all, we're just giving real world context to something you already know, which is how to take 2 points, that point, and these are far away from each other, but that point, and take 2 points and make an equation for it. We practiced that yesterday. All right, so now let's talk about when lines are perpendicular or parallel. Now I know you've done this before. I don't like this slide very much. I'm gonna go over here and just remind you this way. Do you get if I have 2 lines that are parallel to each other that their slopes are the same? Does that ring a bell? Okay. And so if I said I wanted to have you give me something that went through this point and had a slope of 7, as long as I write an equation with a slope of 7, they'll be parallel to other equations that have a slope of 7. How can you go through a point and use a slope? Well, you probably use this one. Y minus y1 equals m times x minus x1. And this should be easy for you. Go ahead, stick the numbers in the right spots, and take that point and that slope. Stick the numbers in. This really only gets harder when you're talking about the real world. What is the 2 comma the 5? Maybe it's like, well, we were thinking it today at work we would make 2, no, I don't know, it's something kind of new and cool. 2 VR systems. Or we could use my daughter as an example. They build stuff, super expensive stuff. They build stuff for Abbott, and she's a mechanical engineer, and so she supervises the line where they build the stuff. And they might make 2 heart monitors on one day, and then also on this other line, they might make 5 of these. Got all kinds of interesting products, like diabetes machines. Like, for example, again, I probably got to be careful what I say here because I am recording this of what she's told me that's not for the public to know, but the things that they sell, for sure, are a lot of medical device type things. So she gets to see really cool stuff that the doctors use when they put the device up into your arteries, and then it goes all the way up to your heart, and then they can like check your heart for like any abnormalities. This little super sensitive thing on the end of the tip of the thing that they shove up inside of you, that thing touches your heart and can tell like, oh, you've got a weakness in this little part right here, and it's got this fancy little way to burn, like a blade, like fix a little problem in your heart, so that you don't have to have open heart surgery. They can just like zap it, like there's a little hole, we can zap it shut, kind of thing. Anyway, so she might be deciding this kind of thing for real about how many are we going to manufacture each day, and would it be more profitable for us to, maybe we should make more of these and less of those. But then again, there's all kinds of complicated factors, like, well, marketing wants us to sell both because the doctors aren't going to go with, if we only make this, even though it's more profitable, they're not going to go with us. So they want a full system that they can use all of our products. So we have to sell them even if we don't make much money. So anyway, it's complicated variables. All right, I hope you put these in the right spots and you said y minus the 5 is equal to m is 7 times x minus the 2. Raise your hand if you had that one right. Okay, good. Now, what if I'd have said perpendicular to that? It would be very close, but I would not have used the same slope. I would have used, do you remember this? Close, not just the reciprocal. The negative reciprocal, you are correct. So not just 1/7, negative 1/7. Let's look at that for just a second with two lines. Let's say I have a slope of 3. It's pretty steep. What would it need to be perpendicular to that? Well, it would need to be like that. And do you get that if this one was 3, this one couldn't just be 1/3 because it's also going down, right? So it needs to be, not y, sorry. It's m would be negative. And then how steep is it? It's not as simple as -3. It's negative 1/3 is its slope. All right. Now I'm going to go back to this because I feel like we're more ready for it. Now, this spot right here and this spot right here are 2 points. And they are a certain distance away. You're supposed to know the distance formula? Take just a second, and everybody, please, right now, write down what you think the distance formula is. Don't try to stick these points in or anything. Just figure out what do you remember being the distance formula. I gave you a little story about a fight club. Did you have square root of, and it doesn't matter if you pick x's first or y's first, but what happens between them? You put a minus because they're fighting, and then I like to say that they're squared up against each other, and that if you walk between the two, you might trip over the plus sign that's in the middle. Raise your hand if you had that one right. Awesome. Now, do you get if I truly have named these 2 points as -1 comma that and +1 comma that? I could put those into my distance formula. So if I knew the distance between the two was going to be like 6, I could put a 6 here. All right. And if I knew this was one of my points, I could put that in for the x and the y. Let's say I put it there and there. And I could put the other one in here. Do you remember the question on the homework the other day where it said you have a line, y equals 2x, and they wanted you to say, okay, from this point over here, what are the things that are 4 units away? Do you remember the question? Okay. What are the things that are 4 units away? So, how would you tell what is 4 units away? Well, if this point was -1 comma 3, if I'm remembering it correctly, I think that was it. Does anybody recall? You guys have better memories than I do. I think that was it. Okay. It doesn't matter that much. I just want you to be able to set it up now. would you agree there's some point in this direction that would be 4 units away? And there's some other point, like down this direction, that is 4 units away. But there's not any more than just 2 points that are going to be 4 units away, right? There just had to be 2. Okay. Well, if this point is a known point, and this point is, I don't know, some distance over and some distance up, what's a good name for it if I don't know how far to the right and I don't know how far up? X and Y. I don't know how far over, I don't know how far up. But wait, I know what Y is. What does it say Y is? Do you get I can replace that Y with a 2x plus 1? That's a weird substitution, but it says so right here. Y is 2x plus 1. So couldn't I put in, instead of Y, 2x plus 1? Yeah, I can. So then my points really are -1, 3, and x and 2x plus 1. Do you get, if I give you 2 points, you should be able to find, a lot of things. The equation that goes through them, or the distance between them. Especially if I tell you the distance is 4, then you could take your distance equation and I could put the distance 4 right there. And then this could be my x and y that could go here and here. And this could be my x and y that go here and here. And then I've got an equation that only has x's in it, and therefore I can solve it. All right, I wanted to set that up with you because I felt like that one was something that represents the type of R3 that we could have on a test. What was the big aha? Not the distance formula. Pretty much everybody knows that. Not the fact that we have a point, -1, 3. I think everybody would know that because it's in the problem. The 2 ahas are maybe that we don't know what this is, so we should use x, y. And then that y is 2x plus 1, therefore I can get it down to just one variable. As soon as I get it down to just one variable, it's not that hard to solve. Okay, that. Take a look at this one. This is going to really be the main thing that we're talking about today, is finding the average slope. Do you get that if I pick this spot and this spot, the slope would be way negative? Well, they didn't pick that. They picked this spot and this spot. So then the slope would be a slight positive slope. What you can do is take all of the different points that you could have picked and average them up, and you can tell what the average slope of this would be. Do you remember the difference? What's this called again? It's kind of like the difference question. Yes. All right. So to do these, we're going to have this little formula. And it's going to say on the interval A to B, that means from here to here, our average slope will be defined as f of B minus f of A. That's the change in the y's. Isn't that basically a slope, right? Because f of x is like y, right? So f of B is also like y. So this is like the 2 y values. And if I'm subtracting them, it's just like doing a slope. I'm just subtracting the 2 y values. And then what are these? Those are the 2 x values. So it's really just more complicated slope. All right. So what if this was 2, 7, and what if this one was 8, 9? Then I just have to put them in. The y values go here, And you're basically just doing a slope again. It's just a slope. Okay. So let's do this one together. 3x to the fourth plus 2. Between 1 and 2, there could be a curve in there. Do you agree? There could be a curve in there. Okay. So we got to figure out when, remember this is not the point 1 comma 2. That's important to understand. This is an interval of x's. The x's are between 1 and 2. You have an x at 1 and you have an x at 2. This is the x intervals. Okay. Can it be 1? No, it's got a parenthesis around it, so it should be a bracket if I wanted it to be 1. Can it be 2? No, but it goes right up to 2. Okay. So these are my x values. Wouldn't it be nice if we had y values? Because then we could have 2 points. And then you'd know how to find the slope, wouldn't you? See what I'm saying? Okay. So what's the first x value? It's a 1. What's the second x value? It's a 2. And then can't you just find the y values? Well, how do you find the y values? Everybody just pause for a second. If you have x equals 1, in your head, stick it in, figure out what y is. Of course, we have to use that. Did you get 5? All right. 1 comma 5. And what if I put in a 2? Ooh, that's a little gross. 2 to the fourth is 16. 16 times 3? 48 plus 2? Very good. Now we've got 2 points. Now would you know how to do it? What would you do? You'd go, hopefully, 50 minus the 5 over 2 minus the 1. Isn't that the exact same thing that they told us to do right here? F of the second one, which is like the y value of it, over the second one. And then this one, I really shouldn't have said it that way. This one, f of the second one, minus f of the first one, as in the y value of the first one, over the second one minus the first one. All right. So what is my average slope? Let's finish this puppy. What is 50 minus 5? 45. 2 minus 1? 1. So it's got an average slope of 45. Do you get if they gave us context, like we're talking about how many weasels per hour you can manufacture in your plant? You sell wooden weasels. Oh, maybe garden weasels. Have you guys heard of the garden weasel? It's this metal rake-like thing that you can row between you can basically hoe up the ground with this garden weasel thing. Okay, I thought you guys would hear of it because it's kind of one of those weird, kitschy products that's been out for a long time. It's the what are some strange products that are advertised on infomercials nowadays? Yeah, I don't watch much TV anymore. What? Tack glasses?
There's always like commercials that everything's $19.99.
Yeah.
And it's
Plus
like
free
that.
shipping and handling.
Yeah.
Can't see anything, but once you get the tack product, you can see everything.
Okay.
The snipers, you can see the eagles.
Yeah, I remember that.
They now have visors.
Oh, where? I've seen that one.
Sounds like a lot of you have seen this. I have not seen. I'm gonna have to look it up now. All right.
Watch during work time.
Flex tape.
This says that the slope is 2/3. Do you agree? Does it rise 2 and run 3? No. If I was going to pick 2 points here, I'd say that this slope has just a slope of 2. Would you agree with that? Okay. If I wanted to be parallel to it then, if this slope is really 2, then what would I have for my other line? What slope should it have? No, you're thinking perpendicular. Parallel. You keep it at 2. Perpendicular, -1/2. What if I really wanted it to go through this point right here, which is the point 4, 5? Well, then you just use point slope. And you use that point and then whichever slope you want. Okay, on that one. Again, more real-world context. This is talking about revenue. I do want to talk about what do you get when you get revenue? That's money that came in to your company. And then revenue is equal to X times the P. The price is P. X is how many you sold. So if you sell these charging blocks here, okay? Battery brick, basically. You know, the battery brick like this that goes in a Tesla is $11,000. Just for a battery brick, except it's much bigger. It's hundreds of pounds. It's really expensive, super high-tech batteries that can cool themselves and have little computers to monitor them. But a brick like this for a Tesla is like 11 grand. Well, this one was only like $29, okay? And it can recharge my iPad a couple times. All right, so anyway, let's say you sell these. If you sell X of these at $20 a piece, you're gonna make 20X as your revenue. Is that all profit? No, that's how much money you brought in. Then you gotta subtract off the costs of making these things. All right, okay. Let's say you had to graph this. Kids usually love these. Do you remember my advice about how to graph these? It's almost impossible. Well, it is impossible to graph them unless you have a number. So what's a good number for A? Well, it can't be like 2 because it says less than 0. So, sure, -2. I like it. And do you remember me saying -1 is not an awesome number to use? Just because ones have weird properties. All right, how about B? Well, B's supposed to be bigger than 0, so maybe 1. But I've told you 1's kind of dangerous because it's got weird properties, so maybe use 2. Then all you're really graphing is y equals, what's the A? -2x minus, what's the B? 2. Could you graph -2x minus 2? I bet you could. That wouldn't be that scary. So these seem impossible until you just stick some numbers in and then you graph it. Okay, so this goes through -2 and has a slope of -2. That's not that bad. There. Is that the only answer though? No, because I now have to say, did I have to pick 2? No. Could I have picked -1? Yeah, I could have. I could have picked -1 here. And I could have picked something else for B also. So there's a whole family of them. So my A here, which was -2, could have also been -1. And the slope of -1 would have been more like this. And you graph a whole family of them. And you figure out where it can't be. Now this one doesn't have any limits on X or Y. So remember before we had to like say, oh, and it can't be, X has to be less than 0, so you can't use that. Or, all right, this doesn't have any of those limits. All right, so remember when you do this kind of question, you pick a number for A, you pick a number for B, and then you keep on picking numbers until you see where that family of functions goes. And you keep graphing new ones, and then you're like, oh, they all end up staying in the same spot. Or if you are unlimited, then you could all of a sudden have positive slopes, which you can't. The slope of 0 is impossible, right? But it'd be right up to a slope of 0, which would be like a straight up and down line. But you can't have a straight up and down line because you can't have a slope of 0. All right, so you keep on trying things and keep on graphing them until you get the family. All right, advice on that. And here's where I want you to actually start your homework for tonight. 12-minute warning. Man, that was good timing. So, remember this is not the point 1, 2. If it was, we couldn't do the problem. Do you get that x to the third is not something we could normally tell you the slope of? Think about what it looks like. What's the slope of that? Well, I don't know. Depends. Do you want the point, the one that goes through here and here? Or do you want the one that goes through here and here? Totally different slope. All right, so we have a formula for that now, though, right? And the way I showed you was to make 2 points, because once you have 2 points, it's just like yesterday, right? So this time you just have to make your own points. What's the first x? -1. What's the other x? 2. And then what do you get when you put in -1? -1 to the third, -1. And what about when I put in 2? 2 goes in here. 2 to the third is 8. And look, I got 2 points. Can you find a slope now? All right. So I'm going to suggest that you do that for 44, 40, and then the 4 at the beginning. All right, that's all I got for you for today. And 46 and 49. This seems big, but it's the same exact concept. You just need to get 2 points. Starting at -4, starting at 2. See what you get for your y's. All right. And then we need to do one real world problem, because I'm warning you, your R3s on the test typically look more like this. Okay, so you got to be able to interpret these things. Don't shy away from them. I know some people are like, oh, it's all these words, I don't know what to do. It's the same thing as we did a second ago. Except instead of saying 0, 12, they wrote it this way. Do you get that kind of means the same thing? So they gave us a 0 as a starting point and a 12 as an ending point. They want you to stick in 4 and see what that means. Did they tell you the temperature? Did they tell you the time? You got to figure that out. Okay, so do number 56. Do those two. You're doing this temperature one. Be reasonable about how much I assign. A one-word problem. Don't skip it unless you're saying, I'll just not do the word problems on the test. Then you'll get a C at test. All right, then we should do a couple of these. This is where they give you a point, and they say, hey, I want it to be parallel to this. Recall that parallel lines have the same slope. So we'll just do a couple that are parallel to. Let's do 60 and 61. All right, so, and then a couple that are perpendicular. We'll do 65 and 70. Some people might look at this and go, what the heck is the slope, Mr. Server? I would suggest graphing it and you figure out what the slope is. Try to remember which way x equals 1 line would go. Hint, the x-intercept is where y is 0, and the y-intercept is where x is 0. So the x-axis is actually the line y equals 0. Okay. And I think that's enough for, so we're not doing the rest of the